So now let's talk about inverse of a function. I hope you all remember when we were studying bijective function, I told you that the functions, those are bijective, can only be reversed. So here also only those functions which are bijective can be inversed. What do I mean by basically inverse? Inverse means that instead of y value, I'm trying to find out my x value. That means my x becomes the output and my y becomes the input for such questions. So here also they've shown us an example. How do I generally find out the inverse of any function? Y is equals to 2x plus 3. So how do I find out the inverse of this? That means I need to make this function in such a way such that it becomes f of y is equals to x. I hope you're understanding this thing. So what I'll do is I'll replace y with x. So I'll write down the entire equation in terms of this format where x is equals to, it is in the function of y, and then I'll simply replace x with y and y with x. So it would become my inverse function. So this is generally how you find out the inverse of any function. Now you must remember this thing, that inverse of a function can only be found out if the function is bijective. That means it is onto or surjective and 1 1 or injective. Now you must be thinking that earlier I had told you about sine inverse x as well. Now if you look at the graph of sine x, how does the graph of sine x looks like? It is somewhat like this, right? So you must be thinking that if the graph of sine x is in this format, then sine x, if it is defined from minus infinity to infinity, it is not a 1 1 function, it is a many one function, right? Because at two values of x, I'm going to get the same value of y. At these two values, I'm getting the same value of y. That means it is a many one function. So then how can I define the inverse of sine? And in fact, there is another chapter as well, inverse trigonometric functions, where we study only about the inverse of those trigonometric functions. So how can I define this? So what we do here is, instead of considering my entire domain or x to be defined in minus infinity to infinity, what I do is I say that my sine x, for my sine x, my x is defined from minus pi to pi. This is what I say. Now what would my graph become? From minus pi, my graph would go on like this and up till pi. So this is basically my pi, this is my minus pi. Now only in this interval, if I look at this function, is it going to be let's say, is it going to be a 1 1 function? Yes, it is going to be a 1 1 function. So that is why now you must be again thinking that here also I have two values for which I'm getting the same y, right? However, it is not the case here. For sine x, when we define it from a function minus pi to pi, we can still call it as a 1 1 function only. Because now what will happen is, for different values of for inverse function, let's say when I define my function to be inverse, sine inverse x, what I say is that my domain basically ranges from minus 1 to 1. Now here, earlier what used to happen was, when I had sine x, my domain used to be x belongs to infinity. Sorry, x belongs from minus infinity to infinity. Now for sine inverse x, it would become from minus 1 to 1. Now again, you will study a lot into detail about inverse trigonometric functions when we study that chapter. But for the time being, just remember this thing. Inverse of function, let's say if I have a bijective, if I have a many one function, still I can make it a 1 1 function by defining it in certain intervals. If it is defined in certain interval, then it becomes a 1 1 function. So that is why we can write inverse of those functions as well. Now there are a few properties that you need to remember. Inverse of a bijective function is going to be a bijective function. Inverse of a bijection is unique, and f inverse, if you take one more inverse of it, you are going to get your original function back. If f and g are two bijections such that g of f exists, then g of f inverse would be f inverse of g inverse. So it basically becomes the reversal order. So this is what we call as the reverse order. Let me write it down once again in a more clear way. Let's say if you have g of f of x and I'm finding out the inverse of this entire function. So how can I write down the inverse of this function? It can be written as f inverse and G is its composite. G inverse is also its composite. So this is how I can write it down. So keep this thing in mind. Apart from that, if we have f inverse of f, it is generally an identity function. Now what is an identity function? Identity function is basically a function which is a multiplication of, or it is a function which is a combination of your original function and your inverse function. So now again, this is a concept that you will be studying in matrices and determinants. There you will understand properly what an identity is. There what we do is, let's say I have a matrix A and I have another matrix A inverse. If I multiply A with my A inverse, what do I get? I simply get identity function as my matrix. So that is what we are trying to tell here. Now let's look at this question. Based on this question, all your doubts would be clear about inverse functions. So first of all, they've given us f, they've given us the domain, codomain, and g function as well. Now we need to find out f inverse x plus g inverse x. So first of all, as we studied in this method here, what we'll do is we'll write down our entire function in terms of y. We'll put x is equals to our y function, and then simply we'll replace y with x and x with y. That would basically become our inverse function. So let us do that one by one. For f of x, what do we have? The function x minus 2 upon x minus 3. So I can write it as y is equals to x minus 2 upon x minus 3. So if I cross multiply, this would become yx minus 3y is equals to x minus 2. So from here, what am I going to get? This would become yx minus x is equals to 3y minus 2. And from here, if I take x common, this would become y minus 1 is equals to 3y minus 2. And from here, x becomes 3y minus 2 upon y minus 1. Now I've gotten my x in terms of y. Now I can simply replace my x as f inverse x basically, and I'll replace my y with x. So this would become 3x minus 2 upon x minus 1. So this is my inverse function now. Now similarly, let me solve for g of x. My g of x was given to me as 2x minus 3. So from here, if I write it as y is equals to 2x minus 3, and if I write down my x, it would become y plus 3 upon 2. Now if I replace it, it would become g inverse of x. This is equals to x plus 3 by 2. So this is my two inverse functions that I've received. My f inverse x and my g inverse x. Now basically I need to find out the sum of these two inverse functions. So if I sum these two inverse functions, what will I get? 3x minus 2 upon x minus 1 plus x plus 3 upon 2. Let me simplify this further. So I would get LCM as 2 times of x minus 1. Here I would have 6x minus 4 plus here I would have x square plus 3x minus x minus 3. So if I simplify this more further, I would have x square plus 3x plus 6x would give us 9x minus x plus 8x minus 7 upon 2 times of x minus 1. So this is my sum of inverse functions that I'm getting. So now what have they told to us in this question? That the sum of these two inverse functions is 13 by 2. Then we need to find out what are the possible values of x. So I have my function as x square plus 8x minus 7 upon 2 times of x minus 1. This is equals to 13 by 2. Now let me simply just cross multiply. 2 and 2 would get cancelled out, and if I cross multiply, I would get x square plus 8x minus 7 is equals to 13x minus 13. So from here I get x square minus 5x plus 6 is equals to 0. And if I factorize this, I would get x minus 2 into x minus 3 is equals to 0. So what are the values of x that would satisfy this condition? It is either 2 or x is equals to 3. Now I will check in my domains whether this is coming out to be true or not. Now if I see for 2 2 is of course defined in f inverse x. Sorry. Now I'll be checking for f inverse and g inverse. So if I get 2, would 2 satisfy this equation? Yes. Would 2 satisfy this equation? Yes. Now I'll check for 3. 3 also satisfies this equation. 3 also satisfies this equation. Now let's say had I received my x as 1, then f inverse x is equals to 1, where x is 1 wouldn't be defined, right? So I wouldn't consider 1 there. That was now again a hypothetical situation. However, we've gotten our values of x as 2 and 3. Now you must be thinking that f, the domain is not 3, right? F is not defined in 3. However, that is not what we are considering here. Our function is f inverse x. So we will check for f inverse x whether our x is defined or not. And for x inverse x, both these values are defined. For g inverse x, both these values are defined. So that means these two ultimately become our answer. And what was asked to us, we needed to find the sum of all values of x. So it would become 2 plus 3, which is equals to 5. And this is our answer. So this is how you solve questions which are related to inverse functions. You first find out your value of x in terms of y, and then you simply replace y with x, and x can be replaced with y or whatever, f inverse x also you can write your function as. Now, here are a few standard functions that you need to remember for solving any questions. Let's say what generally happens is, in questions of JEE mains, they do not give you the function. They are not going to give you the function. You have to assume what the function is going to be. They are simply just going to give you equations of this type. And if your equation is in this form, then you must understand what would be the function that would satisfy this type of equations. So again, it is important for you to remember these standard format of functions. Let's say if you have f of xy is equal to f of x plus f of y, then your function is basically k times of ln x. Again, k is a constant which you would be able to calculate based on the question that has been given to you or the conditions they have given in the question. This type of function can also be considered to be x to the power n. If f of x plus y is equal to f of x into f of y, then it becomes f of x is equals to a to the power x. If you have f of x plus y is equal to f of x plus f of y, then your function is basically kx. So basically the most important ones that you need to remember are this one, and this one. F of x into f of 1 by x. This is equal to f of x plus f of 1 by x. And if f of x is a polynomial, then f of x is equal to plus minus x to the power n plus 1. So let's say if they tell you that f of x is a polynomial, then you can simply consider your polynomial to be in this format. So these are certain standard functions that you need to remember. So that was all about the theory portion in this chapter. Again, the major portion that we studied in this chapter was the types of function and the classifications of functions. Apart from that, I know there were a lot of concepts used in this chapter that you will study further when you study matrices, PNC, binomial theorem, inverse trigonometric functions. However, when you will study those chapters, these things will be repeated again, and you will see that they have become a lot easier when you study the proof based on those concepts. So now we'll start with the previous year JEE mains questions.